Okay, so you know that problem everyone runs into with HDMI cables?
Oh yeah, the 50-foot wall.
The 50-foot wall, exactly. You try to go any further and you just get nothing.
Static, if you're lucky.
Right. Well, today we're doing a deep dive on this little box, the NTI ST-IPFOHD-R-LC-ULC.
Which is quite a name.
It is a mouthful, but get this. The spec sheet says it can send an HD signal 24.8 miles.
And that is not a typo. 40 kilometers.
I mean, how is that even possible? That's not a home theater setup. That's citywide.
Well, it's not magic. It's just a different medium. It's an extender, so it takes your HDMI signal, converts it into pulses of light.
And shoots it down a fiber optic cable.
Exactly. And to get that full marathon distance, you have to use a very specific kind of fiber. It's called single mode 9 micron.
Okay, what does single mode mean in, like, simple terms?
Think of it as a perfectly straight, super narrow laser beam. The light just goes straight. There's almost no signal loss because it isn't bouncing off the sides.
Ah, okay, so it just travels. And that's different from the other type, the multi-mode fiber.
Right. With multi-mode, the core is wider, so the light bounces around more. You still get an impressive distance, maybe 300 meters, which is almost 1,000 feet.
Still great for a warehouse or a stadium, but it's not going to cross town.
Not even close.
But my immediate thought when you're sending video that far is lag, latency. You know, am I going to see a satellite news-style delay?
You'd think so, but the encoding delay is only 100 milliseconds.
A tenth of a second.
Yeah, for digital signage or a security feed, it's effectively real time. You'd never, ever notice it.
Okay, so the physics checks out, but the IP in the name, that means it's a network device, right?
Mm.
So can I just plug this thing into a cheap $5 switch and, I don't know, broadcast to 200 different screens?
You can try that. You'll probably just crash your entire network, though.
Right. And why is that? Just too much data for the switch to handle.
It's more that a cheap, unmanaged switch is. Well, it's dumb. It doesn't know where to send the video stream, so it just floods every single port with it.
It creates a broadcast storm.
A massive data traffic jam. That's why the documentation is so specific. You have to use a managed SFP switch that supports VLANs.
Let's pause there. VLANs. Break that down for anyone who's not in IT.
For sure. So a VLAN is like having a dedicated VIP carpool lane on a busy highway.
Yeah.
It separates all that heavy video traffic from your normal, everyday stuff like email and web browsing.
So the video feed doesn't get stuck in traffic behind someone printing a PDF?
That's the perfect analogy. And with that kind of setup, yeah, you can scale the system up to, I think it's 253 receivers from a single source.
Wow. But that brings up a practical issue for me.
Okay.
If my video source, say a server, is in a locked room 20 miles away and I'm at the screen, how do I control it? I can't just walk over and change the channel.
That's where the IR extension feature comes in. It's really clever.
The infrared remote signal.
Yep. You just stand at the display, point your regular remote at the receiver box, and it sends that IR signal all the way back down the fiber to the source device.
That's actually incredibly useful. And since we're talking about fiber, I'm guessing electrical interference isn't an issue.
Not at all.
Yeah?
That's a huge advantage over copper, which acts like a giant antenna for any electrical noise.
Right, from heavy machinery or even fluorescent lights.
Exactly. Fiber is just glass. It's completely immune to RFI and EMI. You get a crystal clear picture no matter what.
So when you boil it all down, this device effectively just removes distance from the equation.
It really does. It eliminates that distance anxiety completely. If you have fiber running across a campus or a municipality, your video source and your display can be anywhere on that line.
It kind of redefines what local even means, doesn't it?
It does.
I mean, if you can instantly control a machine from 24 miles away, is that machine really remote anymore?
That's the provocative thought, isn't it? We're so used to our physical control being limited by our line of sight. This breaks that rule.
It makes you wonder, what happens when our physical proximity to the hardware we use just stops being a factor at all?